Okay, so let's get started. We're going to talk about right triangle trigonometry today and introduce the trig functions, things that are going to become pretty important in our lives for the next couple of weeks or so, next 5 weeks. Okay, so where does trig functions come from? Trig functions come from, their definitions are generated from a right triangle. And so here I have a right triangle drawn, and few things to be noted. The first thing is the angle. Here is our angle theta, and the angle is the perspective that you're going to take from computing these values off of these triangles. Now, notice that this is a right triangle, and there are 3 angles in a triangle, and theta could be up here just as well as down here, so you must indicate where theta is. If, say, theta was up here in this corner, then the opposite would actually be over here and not what I have labeled. So this triangle here is labeled in perspective of this angle theta. Okay, so the angle theta opposite is always across from the angle, adjacent is always next to the angle, and the hypotenuse is always that angle across from the right angle of a right triangle. Okay, so let's get over here to our functions. There's 6 of them. The first one is sine, and the sine function, and let me give a little vocab here. So this is our sine function, and this is the sine of theta. And I think I introduced theta last time. I'm pretty sure I did. But remember that all of our angles, generally in trig, are going to be done with Greek letters. Like pretty much all of our variables and stuff will be done in Greek letters, with the exception of graphing. When we graph, we go to the x and y plane. But anyhow, this is our theta, and this is also called the argument of the function, and it is made by getting the value of the opposite side, whatever the value is of the opposite side, divided by, or the ratio of, the opposite over the hypotenuse. And so I have written it in both ways, in symbols and in the full words. So you can see here, I'll kind of tick down, but I won't talk too much, but the cosine is from the adjacent divided by the hypotenuse. So here we would go with the adjacent over the hypotenuse. And then tangent, you can see, is the opposite over the adjacent. So every one of these functions is defined by a different ratio from the perspective of the same angle, theta. All right, well, let's see. How does it work? Well, generally, and right now, as we're learning how all this works, we're going to be doing kind of some easy stuff. This isn't what you'll be doing in calculus, but you have to understand how trigonometry works before we can solve the problems that we'll be solving for calculus level problems. So how does this work? Well, first off, you see that we have a right triangle, and there's a really cool thing that we get when we have the right triangle, and that's the Pythagorean theorem. The Pythagorean theorem says a squared plus b squared is equal to c squared. Now, I do want you to get used to labeling your triangle, and so from theta, across from theta, the opposite is actually b, adjacent is the a, and the hypotenuse is the h. Now, I wrote this with a's and b's, but in my mind, I don't think about a's and b's. I think about opposites, adjacents, and hypotenuse. So that's how I'm going to refer to them. I may point out a thing here or there, because the other thing with trig, and as you go further on in calculus and stuff, is they'll ask for the same thing, but couch it in a different way. So maybe put it in a different form, or do something like this where we went from A's, B's, and C's to now O's, A's, and H's. So just hang on for the ride. Okay, so the first thing we can do is solve this triangle, and we can solve the triangle by using the Pythagorean theorem here. And so we have a squared plus 3 squared is equal to 5 squared, and we can just do this. A squared plus 9 is equal to 25. A squared is equal to 16, so A is equal to 4. Now, we're not really going to consider the negative here because we're dealing with measure, okay? And measure is never negative, okay? So we don't want to consider that negative for answer. We only consider the positive. Now, once we've got the triangle solved, and we have the triangle solved now because this is a 4, we can find the values of all these functions. And so let's get started here. So the first function is sine of theta. Now, you must have the argument. You can't just write sine. Okay, you have to have the argument as well. The argument is kind of like an integral part. It's sort of like if we want to write, say, the square root of 2, right? That's common, but you don't ever see just a square root hanging out, right? You have to have the argument of the function. And remember that sine, cosine, tangent, cosecant, secant, and cotan are all functions. Just like the square root is a function, just like a square is the function. You don't ever come across an equation that's just got a hanging cube somewhere that's not attached to a variable. Okay, that variable would be the argument of that exponent. So it's super important that you're always putting in that argument, kind of like f of x. All right, so sine of theta is equal to, this is equal to the value of the opposite over the value of the hypotenuse. So I have 3 over 5. Then we have the cosine. Cosine of theta is the adjacent over the opposite over the hypotenuse. So that's 4 over 5. Then we also have the tangent of theta. Tangent is the opposite over the adjacent, so 3 over 4. And now, this is something else that I always do, and it just kind of concretes the relationships that I haven't really started talking to you about, but I will start talking about, is anytime I'm asked to write out the values of the 6 functions, I write out sine, then cosine, then tan, and then next to the sine here, I'll write my cosecant, because sine and cosecant, as you'll see, have a special relationship. So the cosecant is 5 over 3. You can see that they kind of have a reciprocal relationship, which is in fact what they have. And then I will write the secant of theta. Well, the secant of theta is the hypotenuse over the adjacent, which happens to be the reciprocal of cosine, and then finally that cotan of theta, which is 4 over 3. Okay, so let's work a couple. Now notice I changed the perspective of where theta came from. It's super important that you're not always putting theta in the exact same spot, and that you're not always drawing the exact same triangle when you're working out problems. Because when you're doing, say, a word problem, an application problem, where it is something specific that when you draw what's happening, it is not shaped in the way that you're accustomed to, then you'll have a harder time thinking through it. So it's really important for you to kind of mix it up, draw your triangles in different directions to kind of keep your brain looking from the theta instead of from one specific point that you always look from. Okay, so we'll look at this guy here on the left. Our theta, notice, is up here in the corner. That makes this opposite, this adjacent, and this is always going to be the hypotenuse. Okay, it's super important, especially early in the days when you're starting to work on this, that you label everything. All right. Okay, so let's find our side here. So we've got 2 squared plus, we don't know, that other side squared is equal to 4 squared. We don't really have to be all that technical, right? So our missing side squared is equal to 16 minus 4. So our missing side squared is equal to 12. So our missing side is equal to the square root of 12. Now please be sure that you simplify all of your radicals to the most simplest form. So 2 things here. Number 1, you can't put this in your calculator and give me an approximation unless I ask specifically for the decimal approximation. That's not an exact answer, and I need you to give your answers in exact form. So that's number 1. Number 2, we want all radicals simplified. Also, we don't want any radicals in the denominator, so we have to rationalize everything, and I'll be going over all of that kind of stuff today. So this is the square root of 12, which I believe I talked about certainly at least once during the course of this this class so far. This is 4 times 3. The square root of 4 is 2, and we're left with a square root of 3. So our other side here is 2 square roots of 3. Now the directions are to find the value of all 6 trig functions for theta. Okay, so here we go. I'm going to start off with sine. Sine is opposite over hypotenuse. That is 2 over 4. Please give me all of your answers in simplest form. So that would be 1/2. Cosine of theta is going to be adjacent to square roots of 3 over our hypotenuse 4. Also, simplify this. 3 over 2. Our tangent of theta is going to be our opposite over our adjacent. And this is what I was alluding to a few minutes ago. We cannot have a square root on the bottom. That is not an okay answer. We must rationalize it. So first, let me simplify this. 1 over the square root of 3. And now let's rationalize it. And the way that we rationalize, and you might remember this from your algebra classes, but it's very similar to what we did when we got rid of, when we were dividing by complex number. You had to kind of use the conjugate. So if this was a complex expression, which it's not here, we would have to use the conjugate. But what gets rid of a square root of 3 is multiplying it by another square root of 3, because square root of 3 times the square root of 3 is equal to 3. So that's what we're going to do, and we're going to use that trick of 1. So we're going to multiply it by the square root of 3 over the square root of 3. Hopefully this is very much stuff that you already know. Okay, this gives us the square root of 3 over 3, and that is that number simplified. Now, typically I would write the next group next to it with the cosecant next to the sine, but since I have managed to use up a whole lot of space here, and I have another problem for us to do with limited space because of my face, because I always forget about that, then I'm going to write it underneath here. So the next one in order is the cosecant of theta. And the cosecant is the reciprocal of sine. So I'm just going to do it that way. So I'm going to look up here at my 1/2, and I'm going to flip that over, and that is equal to 2. My secant of theta is the reciprocal of cosine. So that's going to give me 2 over the square root of 3. Now we can't leave it like that. We have to rationalize. So I'm going to multiply that by the square root of 3 over the square root of 3 to get our new answer, which is 2 square roots of 3 over 3. And then finally our cotangent of theta, that is equal to, and I'm going to pick it up right here, square root of 3 over 1, so it is just the square root of 3. Now, we're going to be doing this so much. You are going to be doing this so much. You're going to be like, oh my God, I'm so tired of doing this. But here's your first shot. Here's our first you do. So I'm going to give, I don't know, about a minute and a half, maybe 90 seconds for you to work this problem. Okay, I hope you labeled your sides in perspective of the angle and you got your adjacent and your opposite and your hypotenuse all correct. Let's go ahead and solve this. This is 2 squared plus 3 squared equals the hypotenuse squared. So we have 4 plus 9 equals h squared. So h is equal to the square root of 13. Okay, so let's find all of the things. So our sine of theta is equal to the opposite over the hypotenuse. So 2 over the square root of 13. Now you're going to rationalize so many times that hopefully you'll get to where you can just see it and you don't need to do it. But I'm going to keep on showing the work until I'm tired of showing the work. Okay, and then I should have started over here a little bit further. Cosine of theta is the adjacent over the hypotenuse. So again, we'll have to multiply this by the square root of 13. Getting us this. Our tangent is 2/3. Lovely. And then I'm just going to use that information to get the rest. Our cosecant is the reciprocal, square root of 13 over 2. Well, that's cool. Secant is the reciprocal of the cosine, so that's the square root of 13 over 3. And finally, cotan, the reciprocal of the tangent, is 3 over 2. Okay, awesome. Let's see what's next. Well, let me officially tell you about these reciprocal identities. Okay, so the cosecant, as I have said, you know that they're reciprocals of each other. The cosecant is the reciprocal of the sine, the secant is the reciprocal of the cosine, and cotan is the reciprocal of the tan. Okay, we also have these other identities. Tangent is actually made of sine divided by cosine, so that's a quotient identity. And cotan, because tan and cotan are reciprocals of each other, is then sine is in the denominator and it is cosine over over sine. So let's find exact value of the remaining trig functions using the reciprocal and quotient identities. Okay, so I'm just going to jot a couple of these things down. Now this is my suggestion for you. You should get yourself a piece of paper. Actually, I suggest you keep yourself a little notebook where you can just start. Not a piece of paper, because then you might not find that piece of paper, but you know, maybe a little, a small little memo book or something where you just start writing all of the things, basically starting from here on as far as some of the technicalities, how to find things, steps and stuff, because it'd be a nice little reference for you. But you will get to where you won't have to look at anything with enough repetition. So let's see. We know that, let's see what we need. We need cosecant of theta. Cosecant of theta is the reciprocal of sine, so that's equal to 1 over sine theta. Secant theta is 1 over cosine theta. Tangent theta is equal to sine theta over cosine theta. And cotan theta, and we can talk about this in a couple of different ways, is 1 over tan theta, but that is also cosine theta over sine theta. That's the other thing that makes trig kind of cool, is because you can rewrite it in a whole bunch of different ways. You can kind of use it to your will to fit what you might need for a specific situation. Okay, so we're given the value for sine and cosine, and we are asked to find the exact value for the remaining functions. So let's start with tangent. So tangent theta is equal to sine theta, square root of 5 over 5, over cosine theta, 2 square roots of 5 over 5. Okay, so remember we did a little bit of this. We've got a complex fraction, a fraction divided by a fraction, so we get to stay change flip this guy. So we have the square root of 5 over 5 times 5 over 2 square roots of 5, and when we cancel everything out here, we're left with 1/2. So if tan theta is 1/2, I'm going to go ahead, since we're being asked to find all 4 of them, cotan theta then is 2. I'm going to use that reciprocal relationship that I know there and just knock that one out. Easy peasy. Okay, now let's do the cosecant of theta. Cosecant is 1 over our sine theta. And a lot of times students have some difficulty here knowing where to do the flip, but remember that the numerator is 1, and that is 1 over 1. So all we're going to do is flip this guy over. So this is equal to 5 over the square root of 5. And then, of course, we have to rationalize all of our answers. No square roots in the bottom. So this gives us 5 square roots of 5 over 5. And those guys cancel. And this is just the square root of 5. And then secant, we'll do the same thing. Secant is 1 over cosine, so we have 1 over 2 square roots of 5 over 5. So that allows us to just rewrite this as 5 over 2 square roots of 5. Now here we don't multiply by the denominator, we just multiply by what we need to get rid of that radical, and what we need to get rid of that radical is just the square root of 5. And so now we wind up with 5 square roots of 5 over 2 times 5 gives us root 5 over 2. And there are our other 4. Okay? Let me give you the opportunity to work on this. This is just really you just practicing manipulating all these things. So I'm going to give you about a minute. And I'll write this over here. Okay, let's get to it. Tan theta is our sine theta, 2/3 divided by our cosine theta, square root of 5 over 3. Stay, change, flip that guy. We get 2 over root 5. And we clean that up by multiplying it by root 5 over 5. We get 2 root 5 over 5. Our cotan of theta is, let's see, root 5 over 2. We get to pick it up right here because that was actually the answer, tangent theta. We just had to put it in a cleaner form. So this is root 5 over 2. Alrighty, let's do our cosecant of theta. That's 1 over our sine theta. So that is equal to 3/2. And our secant theta, not quite as pretty, 1 over our cosine. And we'll multiply that. And there we have it. Let me mention one thing here because sometimes people, this is a lot of stuff to like remember. There's a lot of stuff to remember. And one of the ways that I remember this situation here, like which ones are reciprocals between the cosecant and the secant, is I always remember sine goes to the C and cosine goes to the S. In other words, they always go to the opposite letter. So if you're confused, you're not sure if it's secant or cosecant, that is the reciprocal of sine, just know that it's going to be the opposite letter. It's not the same letter. So that'll kind of help trigger you to remember that, maybe. I will probably impart a whole bunch of weird sounding things because when I was in college, there was no page of notes or formulas you could bring in to an exam. By the way, there is no page of notes, so to speak, for my midterm exam either. But we'll talk about that more. I haven't actually made the exam yet. When I make the exam, if I feel like everyone needs something, then I will send out what you will be allowed on Honor Lock to use. You will not be allowed to use just any old thing. Okay, anyway, sorry, I digressed. I didn't want to. but I did. Darn it. I would re-record this. Maybe I can cut this out. Maybe I'll try to edit my video. I don't know. Okay, let's keep on going. Okay. So, one thing that you will be asked to do is to find all the values of a function when you're given the value of one of the functions at the angle. So here we have cosine of theta is equal to the square root of 2 over 2. Now, cosine is equal to the adjacent over the hypotenuse by definition. This is by definition here, right? By definition. So what we can do is we can actually draw a triangle, find the other side of the triangle, or the missing side of the triangle, and then find the rest of the 5 functions. So let's do that. So let's draw a triangle. Two things that you need is you need the little square indicating that it is a right triangle, and you also need to choose where your theta is going to be. I don't think I've done a theta over here yet, so I'm going to make that my theta. Now, I'm going to use the information that we were given in the problem, and we were given in the problem that the cosine of theta is the square root of 2 over 2. That means the hypotenuse is 2 and the adjacent is the square root of 2. And so now we just need to find that other side. So we've got opposite squared. I should have just called, I'm just going to call it a P. Opposite squared plus the square root of 2 squared is equal to 2 squared. So this gives us P squared is equal to plus 2, is equal to 4. P squared is equal to 2. P is equal to the square root of 2 as well. Okay, that's cool. That can happen. For sure. All right, so now it asks us to find the remaining 5 functions. So we need sine theta. Sine theta is opposite over hypotenuse. So we have root 2 over 2. Cosine, I always just write them down anyway. I know that's kind of dorky, but that's just the way I've done it since I learned trig, so I just try to stay consistent. Tangent is opposite over adjacent, which is just equal to 1. Coolio. Cosecant of theta, which is the reciprocal of sine of theta, is 2 over the square root of 2, and here we're going to have to clean that up. So this gives us 2 root 2 over 2, which is just equal to root 2. Secant of theta, which is 2 over root 2. I'm going to write C above. For the steps. And then cotan of theta is the reciprocal there, so I'm just going to write 1. Okay. So let me do another one, and then I'll give you one to do. You know how I do. So this guy is secant. Now, notice that this is not a fraction. Oh my. So what is always underneath the whole number? 1. Secant is just defined as the hypotenuse over the adjacent. So that's the information that we have here. Let's draw our triangle. Let's see. Call this theta. We have our hypotenuse is 3. Our adjacent is 1. We need to find the rest of our values here. So we have 1 squared plus a squared is equal to 3 squared. So a squared is equal to 9 minus 1 is 8. A is equal to 2 root 2. All right, so let's do it. Okay, so our sine theta is going to be, oh, here, let me just label this just to make things easier. Definitely at the beginning it is helpful. This is our opposite. This is our adjacent. And this is our hypotenuse. Okay, so our sine theta is 2 root 2 over 3. Cosine theta, 1 over 3. Tangent theta, opposite over adjacent, 2 root 2 over 1, which is just a 2 root 2. Cosecant of theta, it's going to be 3 over 2 root 2. I have to multiply those by the root 2's. Gives us 3 root 2 over 4. Secant theta is just 3. And cotan theta is 1 over 2 root 2. So we'll have to hit up our root 2's here. And that gives us root 2 over 4. And there it is. All right, so here's one for you to do. Remember that this is over 1. Remember that the tangent is opposite over adjacent. And draw yourself a triangle. Wherever you want to put your theta. Ouch. This is your you-do. In case I didn't say that, I thought I said that, but now I'm not. Now I'm doubting myself. Take about another 30 seconds or so. Okay, we have 1 squared plus root 2 squared equals our hypotenuse squared. So 1 plus 2 is equal to our hypotenuse squared. Our hypotenuse is equal to the square root of 3. And now we can find all of our things. So our sine of theta is our opposite over our hypotenuse. So that's the square root of 2 over the square root of 3. Now we need to clean that guy up. It's okay if there's radicals in top, just not on the bottom. So this will give us the square root of 6 over 3. That does not simplify. cosine of theta is going to be the adjacent over the hypotenuse, 1 over the square root of 3. Gives us the square root of 3 over 3. Tangent we already have. I'm just going to jot it down. Then let's see, our cosecant is the square root of 3 over the square root of 2. So that is going to require us to do this. Now our secant is 1 over the square root of 3, so that's just the square root of 3. Awesome. And our cotan is going to be 1 over the square root of 2. That's going to give us square root of 2 over 2. Yay. Okay. Awesome. Okay. So, because this is a right triangle, and only because this is a right triangle, only because this is a right triangle is this true. But two acute angles are complementary if their sums equal 90 degrees. Okay? And if we're dealing with a right triangle, then the other two angles, angle A and angle B, have to equal 90 degrees because angle C is 90 degrees. So that's all that's left over after you have a right triangle, okay? So what this is just saying is that the sine of B is equal to the cosine of A, and you can see it by just changing your perspective here. And I'm just going to point it out for one of them, and I'm also going to point out the fact that this is not something to memorize. You should change your perspective, your angle perspective. Don't memorize this. But what I want you to see is, if, say we're doing sine, sine is opposite over hypotenuse. So I'm going here from angle B. Sine is opposite B over hypotenuse C. Okay, so there it is. Now let's go up here to cosine. The cosine of A is the opposite, which is B, divided by the hypotenuse, which is C. So you see that also gives B and C. So it's all about the perspective in whatever direction you're coming from. Now there are co-function relationships, and I talked to you about the reciprocal relationships, and this is one of the things that makes trig a little bit overwhelming when you first start learning it. It seems like there's just so many stinking rules, and I thought the rule was this, but the rule is actually that. No, it is really important for you to nail down the vocabulary of mathematics, because that's where a lot of students really start getting confused as we go on into these higher levels. So what I've been talking about so far is a reciprocal relationship. Now what I want to talk about is co-function relationships, okay? And the co-function relationships occur between sine and cosine. They are co-functions. Cosecant and secant are co-functions, and tangent and cotangent are co-functions. And what being co-functions means is that their complementary angles are equal. Okay? And so the way you can get the complementary angle is to subtract it from 90 degrees. Now we're not dealing with degrees here. Remember, we're dealing with radians, but I'm going to write this one relationship for you in the terms of degrees just so you can see it in terms of degrees. You can write all of these out in terms of degrees if you want, but we're not really going to be dealing very much in degrees, and it is super important that I can get you to think in radians as quickly as possible. Now, so remember, that the cofunctions are, and I'm going to write it up here because I wanted to say one more thing, and I switched slides, and you're not allowed to go backwards if you're recording on PowerPoint. For YouTube, you can't go backwards. Anyway, so cofunctions are sine and cosine, cosecant and secant, and tangent and cotangent. And what the cofunction means is that sine of theta is equal to the cosine of pi over 2 minus theta. That's what it means to be cofunctions, that we can rewrite this. So let's take a look. We're going to start doing some math with all these pi's today. So just get ready. So cosine of pi over 4 is equal to the sine of pi over 2 minus that pi over 4. Now, the best way, the easiest way to handle all these pi's is to ignore the pi's and just do the fractions. Okay, so over here I'm going to do a little think bubble here for you to see this. So pi over 2 minus pi over 4 is equivalent to us doing 1/2 minus 1/4 and then multiplying all that crap by pi. I mean, that's the idea. And what's a fourth minus a half? Well, it's another fourth. And so sine of 1/2 minus 1/4 is equal to the sine of pi over 4. Those guys actually happen to be equivalent. Okay? So let's do this one. I think hold on one second. I'm gonna give a quick pausey poo here. Okay. All right, so let's do secant here. The cofunction for secant is cosecant, and it is pi over 2 minus 7 pi over 6. Okay, so let's get over here in the think bubble, and here we need to do the arithmetic on 1/2 minus 7/6. Remember, when you add fractions together, they have to have a common denominator here. The common denominator is going to be 6. So I've got to multiply everybody by something. And so then I wind up with 3 minus 7 over 6, which is negative 4 over 6, which is negative 2/3. So this is going to be equal to the cosecant of negative 2 pi over 3. Okay, let's do the tangent one. Actually, you do the tangent one on you. And I'll give you about a minute. Okay, the cofunction of tangent is cotangent, so this is going to be pi over 2 minus 3 pi over 2. All right, so that is 1/2 minus 3/2. 1/2 minus 3/2 is equal to -2/2, which is -1. So cotan of -pi. Okay. Awesome. All right. Let's keep on moving here. Now let's use kind of all of this information together and then evaluate some of these expressions. So the directions would be to evaluate. Without a calculator, you're going to see that a lot. And that's just indicating that we want all of our answers exact. So first things first, we got to find the secant, cotan, and cosecant. So the only thing we can do is to start off with a triangle. A really crappy triangle, but it's a triangle and that's all that matters. And I got my important stuff here. This is going to be my opposite, my hypotenuse, my adjacent, and then let's put in our values here. We have our tangent is opposite over adjacent. So we've got 7 and 1. So let's figure that out real quick. We have 1 squared plus 7 squared equals h squared. So 49 plus 1 is 50. So h squared is equal to 50. H is equal to the square root of 50, which is 5 square roots of 2. Okay, now let's take a look at another thing. There's just this particular lesson, which there is not a specific homework for this. That's why it's labeled 9.5 out of 24 and not 10 out of 24, is because I was trying to align them all with the homeworks. This is just a whole lot of like skills that you're going to need to have, and I didn't assign a homework section for this because you do these over so many times in the homework already. Okay, so first thing first that I want to point out to you is because of typesetting. I'm going to write something here and then I'm going to erase it. This secant squared theta is actually written like this. But because of the way that things get typeset, if I was to put the square here, you might think that it was just the theta being squared and not the entire equation being squared. So that's first thing first. Anytime you see something like this squared, you want to immediately think this way. Okay? So that's going to be the same case down here with our cosecant squared. This is the cosecant of theta, that value squared. This is going to be the cotan of theta, that value squared, and this is also going to be the secant of theta, that value squared. Okay, so other than that, we've made the triangle. Let's just get the information. So this first one, A, asks us to find secant squared of theta. So we need to find secant of theta. Secant is the reciprocal of cosine, and so secant is adjacent over hypotenuse. So here we're going to say we're going to have our adjacent, which is, oh, sorry, I didn't mean to use this color. We're going to have our adjacent, which is 1, over our hypotenuse, which is 5 square roots of 2, and that whole thing is squared. All right, squared. And when we simplify that out, we get 1 over 25 times 2 is 50. Let's look at the cotan. The cotan is the adjacent over the opposite. So the adjacent is 1 over the opposite is 7. And finally, the cosecant squared of theta. The cosecant is 1 over sine, but we don't have sine, so that doesn't really help us much. It is hypotenuse over opposite. So that's going to equal our hypotenuse 5 square roots 2 over our opposite, which is 7, and that quantity is going to be squared. And so that is going to give us 50 over 49. I don't know why I wrote it in that color, because I didn't change. That will be 50 over 49. Okay. Again, here's one for you. This is the cosecant. The cosecant is hypotenuse over the adjacent. So make yourself a little triangle. The world's worst, but that's okay as long as I call that theta and say that that's a right angle. Oh, that's terrible. I can't leave that. You guys work while I struggle with my triangle. I'm going to give you about a minute. Okay, so let's find the value of the opposite here. We have opposite squared plus 1 squared equals 4 squared. So we have p squared is equal to 15. P is equal to the square root of 15. That doesn't simplify because that is just 3 times 5, so it doesn't simplify. All right, and let's get our sine of theta. That is opposite over hypotenuse, so the square root of 15 over 4. Our cotan is going to be our adjacent over our opposite, so we'll have 1 over the square root of 15 squared. So that makes that work really nice and easy. And finally, the secant. The secant is 1 over cosine. The secant is also the reciprocal of the cosine, but I don't have any of that, so let's just get it. My brain just got distracted there for a second. So secant, my bad. Secant is the reciprocal of cosine, so we're doing hypotenuse over adjacent. So hypotenuse over adjacent. And that asked us to square that, and so we get 16. Sorry, I lost my focus there. Woo! All right, let me take a drink of my water. And that's the end of the show. Well, thank goodness, because I lost my focus. Y'all have a good day.